Hey, good morning, and we are fixing to take some notes on properties of quadrilaterals. You'll probably want a couple of different colors of highlighter and maybe one or two different writing utensils just to kind of keep things organized. All of our notes that we take today will be the entire set of notes for the whole week, and you'll continue to use these notes throughout the week on the different IXLs that you're going to be expected to do. So it's going to be a lot of notes, but we're going to get it all over with, and then we'll spend the rest of the week not doing notes. So the first thing that we need to do is take our sheet of paper. And if you're at home, you can just do this on regular notebook paper and turn it sideways, or perhaps a sheet of printer paper or construction paper will work just as well. And we're going to fold it into thirds. Now, the way you fold it into thirds, you can kind of eyeball it, and you can see where this is about the same amount as this. Or if you don't really like to estimate stuff, you can turn it up on its end and notice how this outside edge is going to be even with this crease and the inside edge is going to be even with this crease, and then you can squeeze. Whichever way you want to work it is fine. But we do need 3 columns on each side. If you're using markers and thin paper, you might want 2 sheets. But if you're in class today, you've got cardstock, and that your markers will not go through. So across the top, and I mean all the way across the top, we're going to put the properties of quadrilaterals, or just properties of quadrilaterals. And we're doing just a little bit of compacting our curriculum when taking notes this way. The book spreads this out, and we just need to move quickly because this year has been what it is. So we're going to go ahead and take all of the notes all at once, kind of like we did with the triangle congruence patterns. The book broke that up, but we did them more together. So properties of quadrilaterals up at the top. In the middle column, very close to the top, we're going to put parallelograms. Parallelograms are the first kind of quadrilateral that we're going to talk about. And parallelograms are a bigger group. They include other smaller groups. So kind of a little bit down, not too far down because you're still going to need to take notes under it, but a little bit down to show that this is a kind of parallelogram, we're going to put rectangles. Rectangles are a type of parallelogram. They have some extra properties that just parallelograms do not have. So all parallelograms are not necessarily rectangles, but all rectangles would fall under the bigger category of parallelograms. And then over to the other side, kind of in the same fashion, we're going to put rhombuses. And then I'm going to put in parentheses rhombi. Sometimes you see that pluralized different ways. Personally, I think it's supposed to be I because US is typically a Latin ending, and you typically don't pluralize Latin endings with ES, but that's a conversation for another day. Rhombuses and rhombi, for our purposes in modern American English, are going to be the same. So this is the first section of quadrilaterals that we have. We're going to first start talking about parallelograms. So our first property, property number 1, is that opposite sides are parallel. So we're just going to write that. Opposite sides parallel. And then we're going to draw a little sketch. Just to give you an idea, we're going to put 5 different items down this list, or down this column. So try not to make yours too large, because we need all 5 to fit with some space similar to this at the bottom. Okay, space for a footer instead of a header. So opposite sides, those would be, in this case, the top and bottom, and the left and right. And parallel is indicated with little arrows. So on the short sides, just for space, I'm going to put one matching set of arrows. So that indicates parallel. If you see those, you know that they're parallel. You don't need the word parallel if you have these two little arrows. And then I'm going to put a different set, two little arrows, to indicate that these are parallel with each other, but not necessarily with the other sides. Makes sense that they're not parallel with the short sides because they intersect. Second property is that opposite sides are congruent. Now, we've talked a lot about congruent recently, particularly as it pertains to triangles, but congruent sides are a major property of parallelograms as well. So congruent just means that they have the same measurements. So I'm going to put marks to show that these are the same size, and marks over here to show that these are the same size. So number 3 actually is a direct result of the opposite sides being parallel. If we have two sets of parallel lines and then they get cut by these other lines are transversals. And you could look at that from whichever direction you want. You could say that the two mostly vertical sides are parallel, and then the horizontal sides are the transversal. Or you could say that the top and bottom are parallel, and then these mostly vertical sides are the transversal. But either way you go, because you have this set of parallel lines and transversals, consecutive angles are supplementary. Now, supplementary, please remember, means that they total 180. You add them up and set them equal to 180. And the reason that that should work, in case you didn't quite follow my ramblings a second ago, you don't have to write this. I'm just going to show you while you are catching up with this writing. Let's say that you have parallel lines and a transversal. These two angles, same side interior, those are going to be supplementary. If we went through and we did stars and circles, right, just like we had talked about when we first started doing parallel lines and transversals, this would be a circle and this would be a star, or whatever shapes you use. These two consecutive angles, they would be opposites, and so they should add up to 180. Well, look what happens if you just continue these lines and then you make another line parallel to this one. It's the same set of angles. And so this is literally the same layout that you get on every side of a parallelogram. So when we draw that, I want us to label one of these with a single curve and one of them with two curves. And then what I want us to do is just to kind of draw some dotted lines that extend our bases, or our sides, I guess, to make it look kind of like a hashtag actually, but to show the intersection of these parallel lines. And then let's get our highlighter, whichever one you want to use. And we're probably two highlighters. We're going to highlight the consecutive angles because it's not just this one set that I drew. These would be consecutive. These would be consecutive also. And then getting another highlighter. You would also have a consecutive set going side to side. So these would be consecutive, and these would be consecutive. So we're going to put over here 4 sets of consecutive. 4 sets of consecutive angles. Okay, so it's not just these two that I marked. That was simply an example. Also related to this, number 4, is that opposite angles are congruent. Opposite angles, I'm just going to put the symbol for congruent. And then once again, let's draw ourselves a parallelogram. Now your opposite angles are going to be on the diagonals, corner to corner. So this bottom left and this top right. And then separately, the top left and the bottom right. And this again comes from the fact that these opposite sides are parallel. Because you have two pairs of opposite sides, you could prove that this bottom angle would be the same, like if we were using this up here, since this has our lines extended. Let's say that this bottom angle, this is going to be corresponding with this one up here. Then you've got these two parallel lines kind of slanting downward, and this angle and this angle would be alternate interior. So they would be congruent also. So since both pairs of lines are congruent and parallel, you can make this relationship between the opposite angles. Okay, so opposite angles are congruent. And our last property under just the parallelogram heading is that the diagonals bisect each other. But I want you to make sure you understand, just because they cut each other in half doesn't mean they are the same size. Okay? Just because they cut each other in half does not mean they are the same size, because they are not. That's a terrible looking parallelogram, but one diagonal is going to go like that. The other diagonal is going to go like that. And when you mark them, that diagonal is cut in half. This diagonal is cut in half. That's the midpoint of each one, but they are not necessarily the same size. If you really are struggling to kind of see how that's the case, let's draw a slightly different parallelogram. Maybe we draw one that is much longer than it is wide. Okay. One of these diagonals is going to be shorter. See how these are just almost on top of each other already? That's going to be a much shorter diagonal than this one that has so much more space to travel. And the more exaggerated your parallelogram is, the easier it will be to see that. Okay, so those are your properties of parallelograms. All parallelograms, including rectangles and rhombuses. And because these 5 properties are also the properties of rectangles and rhombuses, when we start numbering those columns, we're actually going to start with number 6. So opposite sides parallel, opposite sides congruent, consecutive angles supplementary, opposite angles congruent, and these 2 properties come from the fact that the opposite sides are parallel to each other. And then the diagonals bisect each other. This comes from the fact that the opposite sides are congruent to each other. All right, so on rectangles, we kind of drew this arrow down to show that rectangles fall under the umbrella of parallelograms. So the first thing we want to write up here is all 5 parallelogram properties. All 5 parallelogram properties. Plus, and then we'll start with number 6. This one's only going to have 2 additional properties. So on a rectangle, most notably, the angles are different. Your rectangle angles are all going to be right angles. So we're going to say all angles are 90 degrees. Now, on a rectangle, because it is a parallelogram, you only need one of them marked. If you have one of them marked, you know that the opposite one is congruent. So that one has to be 90. And you know that the consecutive ones above it and beside it are going to make it add up to 180. And 90 plus 90 is going to be 180. So in parentheses out here, only one needs to be marked. And then we're going to just draw a little arrow over here to reason 3 and reason 4. As long as you see one marked and you know that the opposite sides are parallel and congruent, then you can know that it is a rectangle. All of the other three will have to be, they will have to be 90 also. Number 7, last property under rectangles. In a rectangle, the diagonals are congruent. Now, they do still bisect each other because all parallelograms have diagonals that bisect each other. But because a rectangle has the same length and width in one direction and the same length and width in the other direction, and you have right angles in all the corners, it basically uses Pythagorean theorem to determine the length of the diagonals. So let's draw ourselves a little diagram and show how that is going to work. So there's our rectangle. Our diagonals run across corner to corner and corner to corner this way. So let's make these sides, maybe this one right here, I'm going to darken it a bit. Maybe that one is 4 units. And this one up here, let's say this one is 3 units. So what we have over here to the side is a right triangle. You will have to do this sometimes to determine how long the diagonal is. In fact, that's a very common thing you'll have to do. Sometimes you might even have to determine how long a piece of the diagonal is, because you would also have to know then that the diagonals bisect each other. So if you had a side of 3 and a side of 4, you would do 3 squared plus 4 squared equals c squared. And c is going to be 5. I hope you remember those Pythagorean triples. 3, 4, 5 is just a set of whole numbers that satisfy Pythagorean theorem, so it's worth remembering. That way you don't have to do all of the math involved. And then look what happens the other direction. I'm going to shade this one in one color with my highlighters. So there's one diagonal. The other diagonal goes the other way. There are a couple of different ways that you could shade that. It's just that this has to be the hypotenuse. So you could shade the top and this side, or you could shade the bottom and this side. It really doesn't matter. I'm just going to do it this way. So in this layout, we now just have a triangle that looks like this. The height is 3, the base is 4. It's the same triangle. So the diagonals can be proven to be the same. I'm going to kind of color these in a little bit as well to show which one is which, although I hope you can tell. Okay. There we go. So that's it for rectangles. Rectangles are parallelograms where all the angles are 90 degrees and the diagonals bisect each other. As long as you know one of those things, you can be sure that the parallelogram is a rectangle.